Welcome back. This is part 2 of pulling back the curtain in Applications Journey to Openshift 4. And in the previous episode, we took kind of a monolithic back end, and the application that we're working with is called Abe Korn. You'll kind of get a little bit more familiarity with what that is potentially in this episode, but we're going to focus on event-driven architecture. And we want to start adding some of those capabilities into the application because one of our goals during this transition is to start making it easier to maintain by decoupling a lot of the back-end services from each other and allow them to run separate in different containers. That is important for a lot of different reasons, but one of the main reasons that we want to allow our applications to be separate from each other and make it easier to deploy them individually is to increase the velocity of our organization. And that velocity is the amount of time it takes from when you start writing the code to getting that code into production without failure, or if there is a failure, it's important to reduce the amount of time it takes to recover from that failure, as well as minimize any impact that you have on the rest of the running system. I don't want to spend a lot more time on introductions, but we do have to have a little bit more context on what it is we're going to accomplish in this episode. So the long story short is we are going to implement the Outbox Pattern. And the Outbox Pattern is the foundation. It can be used as a foundation for something that's very similar to event sourcing, if you're familiar with that. And I don't want to go into great depth on what event sourcing is. That's something that you can kind of search around and look up. But we're going to be implementing something very similar to event sourcing, but I think in a much simpler, more practical pattern called the Outbox Pattern. And we're going to put that example to work inside Abe Korn. We are going to be using Openshift 4 to install a product called AMQ Streams, which will help us create a Kafka cluster with the help of operators. Now, unlike what we did in the previous episode, where we were customizing our installation of EAP or Wildfly using Docker files, we are going to instead take advantage of the cloud-like experience that operators provide to install our Kafka cluster or AMQ streams. Now is a good time to get a bit more acquainted with our application Abe Korn and see what effect we intend our foray into event-driven architecture to have on our application. To do that, let me switch gears here and share my screen. So what is Abe Korn? Abe Korn is a math trading application for board games. Rather than tell you what math trading is, I think it's a good idea to show you. So let's get started. All right, so let's say I have something that I would like to trade. I've got some board games. I come in here and I've created a trade for our demo purposes, and I've called it event-driven demo with just very few. So there's oftentimes tens of thousands of items, or at least 10,000 items in one of these trades. And so I've just added 4 items to this trade, but I'm going to add a board game that I want to trade. Well, I would be adding a game that I have. Let's just say anything, something strange. It uses Elasticsearch, so we can, all right, Hanaji. All right, that's close enough to HOJAOJF that I typed in. So let's say I had this game, and I said it's new in box, NIB, new, and then I add an image. So remember, I'm initially saying, hey, this is new in the box. And I'm going to submit that. It goes into the trade. So it appears now. And let's say somebody else comes along and I log out. So I'm going to log in as another user that I know. So right now there's 3 people in this trade. So there's a BN and another user. So let's go to trade sell, and then we'll go to this event-driven demo. All right. So I'm looking in here, and I'm liking what I see, so I'm going to click these hearts. Yeah, I want this, put that on my wish list, put this all there. Okay, so now I'm going to go to make trades. And then whatever wasn't already in what's called, my matrix, but I'll show you that in a second. This is your queue or your wish list, and you have to accept your wish list. And so I'm looking through here, and I'm going to look at this point because in the previous page, right, everything was consolidated. So under these, I don't see the condition because there could potentially be 2 associated. So like this one had 2 used in new offers. So what I'm going to do is come in and I'm going to make trades, and that goes to my wish list, and then I can see the individual items and what their condition are. So it's new inbox. Yeah. I'm going to accept that. I want to put that in my actual wants. And then I could put in cash offers here, or a value to help fill out this matrix. But we can do that more succinctly in the next page. So I'm just going to let's say I put a bunch of offers on here, like $44, 22, 33, 34, 44, 12, 11. And I'm not going to put in values because this isn't about this. This is just about showing what we're going to do with our event-driven architecture. So under halves, I've only added 3 items to the trade, but I could put in my minimum amount that I'd be willing to trade that for, like $22, and my other, my World of Warcraft is $22. And then I can go to my optional matrix, and I see here on the left-hand side what I want, and up on the top what I'm, willing to give up, as well as some, as you saw, you put in some money, but that doesn't show up in the matrix. And I'm just going to go along the lines here just so we can maximize the number of trades. So I'm just going to say I want everything, and then I've got my cash values in there. I'm ready to go. So there's nothing left in my wish list. All right, so let's go and log back in as the admin, me. So I'm going to log back in as me. I'll go to that trade, and I can get there by going to actually in the browse all section 2. I can click on the trade name, and then let me do my matrix and my wish list. So I don't have anything in my wish list because I haven't wanted anything yet. So let's say I come in here. I'm just going to add all of this stuff, even if it is some of the games that I've added. Doesn't matter. The system will figure that out. It's just, hey, I want this. It's on my wish list, so I can come in and make trades. All right, I'm going to add that. So good condition, new inbox. Yeah. All right. So let's go ahead and let's assign cash values to some of these. Maybe 45, 33, 22, 34. Okay. Going to my optional matrix. Let's say we want all those. And then there's a third user too that I've done some, wanting in the background. But once the actual timer runs out, let's say the timer runs out now, but this has 12 days left. This is just an example event, but I'm an admin. I'm the person that's hosting this trade, and I can come in and I can go ahead and process those trades. And an algorithm runs to figure out who gets what. So let's see what, so there's 7 items trading, and then, so Flubby Bubby is going to get, he's going to give $60, and he's going to end up receiving, in here, he's going to receive the World of Warcraft game. And then, if I were to go ahead and finalize results, people would get notifications. So I'm not going to do all of that. But so so that's kind of showing how the mechanisms all work for math trading. So hopefully it makes a little bit more sense now. And then let's say I were to, before the trade ends, for instance, Let's say I were to go in and modify one of my conditions on my items. Somebody has already wanted it and they don't realize. So if I came in and let's say I edit my items while the trade is still going on, and somebody wanted my new in the box, still in shrink board game of World of Warcraft. At least they thought it was new in the box until I came in and then changed it to, well, it's just okay. Oops, I hit a wrong button. Okay. So just okay. And then we maybe put in acceptable. So we've changed it on them. And then submit. So right now, if Ben were to be logged back in, he doesn't get any notification about that. And we want to provide a notification. And there's a number of different ways that we can implement that. And I have implemented it in a way that a batch application runs and it records all the items that have been modified and then batches that up. But instead, we're going to use Kafka and send an event so that whenever an item gets modified, we're going to pick up a message about that modification, and then we're going to choreograph sending notifications to everybody who might have wanted that item. So if I log out as Dean Peterson and log back in as Ben, just to show that we don't have any notification right now. So right now, there are no notifications that that item has been modified. Okay, that was probably more than you wanted to know about math trading, but I think it's important to set the context and also show it in this form too. So we're going to be implementing the Outbox pattern. We're going to create a new table that will just record the event of a trade entry. So that's what we call each one of those items, a trade entry being modified. So the actual type so this type is the type of event. So we're going to create, so we're going to be using MongoDB. That's the database that's used for this application. And inside the database, we're going to be creating a new table that will just store the events that occur when an item gets modified. So right now we're just going to store the trade entry modified type event. And you could start creating other types of events too. But right now we just have the one. And then that will go into and we're going to show how to set all of this up. It goes into this Kafka cluster, but there's something called Kafka Connect that will be running a change data capture plugin, and it's being implemented via a project called Debezium, and Debezium has a number of different plugins for various types of databases. And the benefit of doing it this way is if we were just going to, in the same transaction, right, Kafka is a separate system that doesn't participate in a transaction with MongoDB. So if we tried to both change the trade entry and send out an event to Kafka and expect them both to be in sync and both to occur, they might not both happen, and then we'll be out of sync, and that won't be a good thing. So by doing it with the Outbox pattern, we can have, and we don't observe using change data capture. We don't observe the actual trade entry table. So there's a trade entry table that has the information about all of the fields in the trade entry. What we're really interested in is the event that, hey, this thing was modified. So we can create a separate table and then put to that table at the same time, and in the same transaction, we're changing the trade entry table. That way we know both of those are going to happen, and then this Debezium plugin can listen from the outside. So we can let that transaction happen, and then Debezium can look at this change log of MongoDB, and we'll never lose what happened there. And so if there were any failures along the line, the change data capture piece will always be able to try again, and then we can route that change to the Kafka cluster as an event. And then we're going to create this thing called a notification service, which will use Fuse to consume the message. So that's what we're going to do in this tutorial. So hopefully that was concise enough, and we're going to start actually implementing all of what we just talked about here. Let's bring up the instructions. So I have some instructions to help us out, and I will share these on the YouTube video too. And the first thing we're going to do is log in to our Openshift cluster. And I have that here. We're logged in. Let's just go back and look at the main status page. Okay, we're going to go to the Operator Hub. And Operator Hub is where you can get a lot of nice functionality just out of the box with Openshift 4, and you don't have to do a lot of customization like we did in the last tutorial. All right, AMQ streams, there's an operator for that right here. That's what we're going to be installing. You can install it in a specific namespace and only have it be available in that namespace, and then you can have an external route to it. We are going to create an external route to ours, but let's also allow that cluster to be accessible, our Kafka cluster to be accessible to other namespaces just by default. So we're going to install it in the default namespace. Let's go ahead and say, well, you know what? Actually, let's go ahead and put it into its own namespace. Let's call that namespace, let's go back home, projects. Let's create a project. Let's call it my Kafka cluster. Looks like I was going to do that anyway. So my Kafka cluster. All right, let's go ahead and create that. And then let's put our AMQ streams operator in that namespace. Let's go ahead and install it. Specific namespace, my Kafka cluster. Yeah, that looks good. And at some point you will see the operator appear under the installed operators section. Now this operator here is not what we used in the last episode. This is an operator for Wildfly itself. So if you wanted, you wouldn't have to do all of the customization that we did in the previous. You know, that was just a very useful demo. And it was something that I needed to do because I still use an old version of Wildfly, but you can get Wildfly right out of the box too as an operator in OpenShift. So AMQ streams operator is installed now. You saw that appear. So let's go ahead and click on that. And operators create new custom objects that are first-class citizens inside Kubernetes, and Kubernetes knows about them as though they are a thing. So just like you could say, hey, install, like get me the pods of this application, you can now say, hey, get me the Kafkas of, say OC get Kafka. Right, we're going to create a Kafka cluster. And it's as simple as just clicking that, but we are going to make one small change because we're going to create an external route. Now, unlike we can't just say OC expose a specific service. We need to instead modify the custom resource YAML for this Kafka cluster and say that we want our listener to be an external listener of type route. So we're going to go ahead and copy that. So it's important not to remove this plain TLS. So I will update the instructions to also include what already is in there. If we were to remove those, that would cause issues. And all we're going to do is add this external type route to this location right under TLS, and remove that space. And once it looks like that, you've got your listeners, you have plain TLS and external. You can make, external needs to be in line with plain and TLS and type route. And you can go ahead and hit create. And we can click on it and go to resources. And over time, there will be a pod. And the key thing about operators is there's a pod that replaces a human being for some of these more complex type workloads. Whereas before you would have an admin that was maybe running some Ansible playbooks or some Chef or Puppet scripts, then instead you can have, just like an application runs in a pod, you can have this other pod that runs as an application, and it acts as a person, and it can continually do the things that would be required to set up something complex like a Kafka cluster. So it runs these reconciliation loops, so if something fails at first, it can go back and try again and do things in a certain sequence and order to make make something like this happen in a very reliable way. And that's what's happening right now. So you see that this replica set of the my Kafka cluster, or my cluster Kafka, is being geared up, and then we've got our zookeepers coming online too. And once that's all complete, we can go on to the next set of instructions, and we need to create the Kafka Connect S2I image for our MongoDB Debezium plugin. And that will run alongside our Kafka cluster and do the work of monitoring our MongoDB database for changes, basically, our Outbox table, and not the trade entry table itself, because all of those changes would get difficult to kind of manage. The Outbox pattern makes it a lot easier and practical to just look at, okay, we've created a new record in the Outbox table, and that is the event we're interested in. So then we get a full record of that as a message inside Kafka, and Debezium combined with Kafka is making that happen. So the next step that we have to perform, now when we are installing the Kafka Connect S2I image, that relies on a container itself, and we have to make sure that we have permissions in this namespace to pull from Red Hat.registry, from the Red Hat registry. And that's what this command will do. So we're going to create a new generic secret, and we're going to give it our auth.json file, which is when you were installing Openshift 4 in Amazon or wherever, you had to get access to your pull secret, and that's what we're going to put in a secret inside this namespace. So when I do OC project, okay, we're not in the right project yet, so we want to go into our Kafka cluster project. So it's my Kafka cluster. Let's do that. OC project, my Kafka cluster. And then we're going to run that command. So OC create secret generic my secret from, so if we do an ls, I'm in the right directory. So I downloaded my pull secret, put it into a file called auth.json that you see here. And that way, if I run the following command, it will work. So I can say OC get secrets, and it is in there, so my secret. But we also need to link it to the builder. So copy and do that. That way when we do the next step, we're going to go back into our Openshift console now and create the Kafka Connect S2I component. So let's go back and look at our installed operators. And you'll see this Kafka Connect S2I custom resource. We're going to go ahead and create that. This we can leave the way that it is, so we'll create it. And if we hadn't put in that secret, when we went into the images, so let's go under our builds, go to image streams. So there are two images that are created. So image streams that are created, and we need to be able to pull the images from registry.redhat.io. And if we hadn't done that secret just now, we would have this would not be present. So everything looks good, and we can go on to the next instruction. So use the OCP. So we're going to download the MongoDB connector. And if you don't have it already, so I have it on my machine. But if you don't have it, you would go and get the MongoDB Debezium connector that you're going to inject into a container for that Kafka Connect S2I component. All right, so here is so you would go to developers.redhat.com, products, AMQ, and download. And then you see here the MongoDB connector for Debezium 1.0.0. Okay, so I already have, and then what you would do is you put that connector. So if we go back and look at, so let's go and look at where I have those. So if I'm going to go under my Debezium folder, and you would create a folder, call it My Plugins. So I've got this folder here, so My Plugins. Let's go into there, My Plugins. And then you would just drop in, so when you download this MongoDB connector, it's going to have a folder called Debezium Connector MongoDB. You would drop that into your My Plugins folder. And then that way you can perform, well, I had this was for other instructions, so I put that into an S3 bucket. But you would do it differently. You would download your connector from this location, or you could download the connector if you wanted to automate it and put it into your own location, and then do a wget, and then extract it. But we're going to then do a build of that plugin and get the actual Debezium connector performing its job inside for Kafka. And that we do with this command. Copy. Okay. So OC start build my connect cluster connect. And the reason for that name, if we go and look at what do we have here under our status, so we've got my connect cluster connect, and that deployment config was created when we did the when we went in here, go into installed operators, connect, and we created that Kafka connect S2I, so it created this my connect cluster, and that generated the deployment config that we're interested in here. So my connect cluster connect. And we're going to start a build, and then this build will take that image stream that we showed earlier, inject the connector, so it will inject this new plugin into that image that we pulled down. So let me show it again. So if we go under our image streams, this my connect cluster connect image stream will, so using this source to image deployment strategy or build strategy, or it will take and combine our plugin with this image stream to have the final image that we're interested in running, which is our MongoDB plugin. Okay. So we started that build. There's a build running. And let's look at the logs. And you want to make sure that it successfully finishes all of the way. And it finished, and you want to be able to see that the push was successful. So now that the push was successful, you should see back under the project a pod running for this deployment config. And let's go and look at that pod. We're going to make sure that it looks like it's running successfully. So far, everything looks pretty good. Okay. The next step that we have to perform is getting it connected correctly via a put command using something like Postman. But we need an external route to what we just created, to the service we just created. That's running our Debezium plugin. Now we do OC get routes. We do have some routes, but these were routes that were created when we specified that our Kafka cluster should be accessible via an external route. But if we do OC get services, then we'll see that, so we've got this my connect cluster connect API service, but it does not have a route yet. We want to expose that. We have to say service. There. Now if we do OC get routes, we'll see a new route, and this is what we need. We're going to copy that. Now that we have this, we're going to open Postman. So when Postman is opened, right, so we're going to put in we're going to create a put request, put the URL that we created. So that URL has the exposed route to our my connect cluster connect API service that's running our Debezium plugin, along with connectors, Debezium connector, MongoDB config. And then the body that we want, we need to look at and have our Outbox table prepared before we run this, because what we're configuring and sending to the Debezium plugin that we exposed is a request to start monitoring our Outbox event table. Let's look at our Outbox table inside MongoDB. So it's not very complicated, and actually we don't need to permanently store it. You'll see that in the code in a second. We just need it to get in there, and then we can immediately delete it because change data capture is monitoring that operations log, and we don't actually need the information in there. Now, right now you can see I'm just storing the type of the event. We might want to also store inside this message what specifically changed that would make the service we're creating or the event we're performing a little more useful. This is what's in that event and in the Outbox event table. So how do we get those into the table? It's just like, well, it's not, so when we have a trade entry, like somebody goes and modifies their item when, as I showed you, the adding an item, putting in the condition information, you click submit, you create a trade entry object. So we're not monitoring this table. So we've got trade entry, but then we also have an Outbox event that's associated with modifying anything inside this trade entry table. So I've got a trade entry creation, and when this thing, so when we persist our trade entry, we're going to fire off a trade entry modified event. And one of the nice things about JEE is you get a lot of a nice functionality that will give you the ability to observe something like this and then use an entity manager to persist a new entity object. So I've got the Outbox event, which is just an entity object, and when we do a modification or an insert, if the item has been modified, we fire off a trade entry modified event, which is this, so that we have an observer. So whenever we create that object, we have an event sender that is observing anything that is associated with an Outbox event or a trade entry modified event, and then it's going to create a new Outbox event item and persist that, and then you can see that it can immediately remove that item too. And once that goes into the table, then our change data capture component running in Kafka Connect S2I will see that and create a new message inside Kafka. And in order to now set that up, we have to take our instructions. Don't worry, the passwords that you see here are no longer valid by the time you are watching this. I have already changed them. So if we copy this and put that into our Postman request, and that should be JSON. Whoops. No, there we go. Okay. Now I will pause this and change the username and password to what it should actually be. 1 second. Okay, so when you finally run that, and you should get a response back that looks something like this. If you get something that looks like HTML, it didn't work, and you'll get an error message. But your response should look like that. Okay. You can go back now and look. When you take a look at your installed operators, and go under AMQ streams, and then you can take a look at your Kafka topic, and you should have your Outbox event topic created for you there. And now Debezium is listening, Kafka is consuming those messages, or not consuming, but the messages are being propagated and pushed into Kafka. Our change data capture component, Debezium, is generating events whenever we create when we modify our trade entries. And now we need to consume those messages that are being sent to Kafka. There are a few ways you can do that. You can do them in low-code, no-code ways using Fuse Online. We're not going to use Fuse Online. Instead, we're going to write some code, but we're not going to write very low-level code. We're going to still use Fuse, and we're going to be using Apache Camel, and Apache Camel has a number of plugins and enterprise, so it implements a number of enterprise integration patterns, and there are plugins for Kafka, and then we can just like we did for our backend REST services from the previous video, we are going to separate out our Kafka consumer into its own project. And I've done some of that work here already. So what we deployed in the previous video was this trade RS. It had dependencies on these other projects, entities, and file utilities. But now we've separated out our consumer. And I just want to show some of the code here. It's very simple code. We're not going to have to write really low level when we consume from Kafka. So if we pull Kafka for any changes, we don't want to write any of that low level code. We're going to take advantage of Apache Camel, and it's just pulling in. So we're using the public, so we're using the exposed routes to our Kafka cluster. And then we do have to do a few more steps to extract our certificate and then include that in our keystore on the machine. So I've done the work here, but we still have to extract our using this command here to run this OC extract command to get our secret. And the secret that we're trying to get, if you were in the project, my Kafka cluster that you created, that you installed your Kafka cluster on, there is a secret installed, and it's called my cluster CA cert right here. We need to extract that and install it into a keystore in order for our external application to be able to communicate with our Kafka cluster. So let's go ahead and do that. And run that. And then when we run that, you will see inside so I actually installed, so I ran that command and I put the certificate in a specific location. So I ran it previously. I didn't actually put it in this location, but if you were to run it, it will output to whatever path that you include. And the path that I included was Kafka certs. So CD Kafka certs. We're doing LS. So our CA certificate's there. And I'm on a Windows machine, so I just downloaded WinSCP, and then I'll log in to my and download. So we need to go to Kafka certs. So we'll download that certificate, bring it onto our local machine. Once you download the file, put that into a location of your choice. I've put that into a folder, and we're going to run a command to take that CA cert and import that into a keystore.jks file. All right. We're going to run keytool import. Okay, that was added. And now we have a keystore.jks file. And if you have not watched the part 1 video, this might be a little confusing, but I'll try to do my best to not make it confusing. We're going to put that keystore file into the trade service base layer of the custom Docker file that we've used to create these Wildfly backend services. So I have to put that new keystore and overwrite because I've done this previously, but now that I've replaced the cluster that I have running in Openshift with a new cluster and has a new keystore, I need to rebuild this image, and with the code that we've got here that can consume the message, and once it consumes the message, it extracts what information was in there, what trade entry ID it was associated with, and then it will send out a notification. So this process, so trade entry modified dot process, will do the work of getting the users to notify and then sending the notifications to any of the users that had previously wanted that item. So let's build the new image and deploy it on Openshift that can consume the messages, put it in its own namespace. So let's copy our new keystore into that Docker files repository and then upload it. So it's trade service base. We're going to paste over, so we're going to replace the file in the destination. And then I can't show you because remember, so trade service base has some passwords and other things in there that I don't necessarily want to show. Well, I don't want to show, I can't. So I'm going to all I'm going to do is go into the Docker file, change the, so this is the builder. So I'm going to do a cache bust, and then I'm going to save it and upload it. So let me do that really quick. I updated the trade service base with the new keystore. Ultimately, what we're going to do is build a new image, this trade Kafka consumers image. You've seen a lot of this work in the previous video on part 1, so I want to go through it quickly. I don't want to completely skip over and have just a completely built image, just because I think it it kind of helps to see things multiple times. That helps kind of the learning process. So let's quickly, again, what do we have to do to get that into Openshift? So we're on our Linux machine again. We're going to make sure we're in the right project. We'll see project, and we are, but we have to log in to the registry. So let me do a history. So let's first log into the Openshift registry and just make sure that all of that is set up. So we need to go and get that host, right? The command to set that as an environment variable. That gets our registries, our Openshift registries route. Once we have that host variable set, we have to also use it to log into Podman. So that's what I'm doing here with this sudo podman login. And we'll put in the password there. So we're logged in. We're not going to push to the registry right away. OpenShift's registry right away, but it's good to have that already done. Instead, what we need to do is go back and look at what our Docker file is. So what we're eventually going to be doing is finally building this. It's very similar to the trade service Docker file. It's almost identical, except we're going to be the code that's being changed is just the code that is consuming the messages from Kafka and sending out notifications. So here we go. With the trade Kafka consumers, the first thing that we're doing is we've made our changes. So we've added that new keystore.jks file to the trade service base, and I pushed that. So I did a git add, and then I pushed that to the Git repository. Now on our remote machine, we're going to pull those changes, and then we have to do a sudo podman build -t trade service base dot, and it will take some time to build that base. So trade service base has finished building, and we will need to use that for our trade service builder. So because trade service builder is dependent on that trade service base, we will also have to update this layer. So I'm going to do a cache bust on that too, and go back one to trade service builder. I'm going to do a git add star, git commit cache bust origin master. Okay, and then we will go to the remote machine, do that too. Now we will pull the new cache bust change. All right, and we will do sudo podman build -t trade service builder. Oh, sorry. One thing that we need to do before that is we have to push to Amazon. All right, let's go to because I'm using the Elastic Container Registry as kind of that redundant intermediate storage for my containers. ECR. All right, trade service base view push commands. We need to log in. Control A, sudo. Now we need to tag that image. And replace all Docker commands with podman. And finally push. Okay, and once that is complete, so I think we can probably just describe, right, so what we're going to do next, what we just did with Trade Service Base, we will do with Trade Service Builder, because there's another layer in between, and then finally we will build the trade service, so trade Kafka consumers layer, and then we can finally push that to the Openshift registry. So I'm going to stop the video here and then pick up where we're finally pushing into the Openshift registry. The image is now created. We are at the step where we need to push the image into the Openshift container registry. So congratulations, you've made it this far. You're probably the 0.01% that has, but you're, I'm sure, better off for it. So thank you for sticking around. And we're going to now do the steps required to get that image into Openshift and run some code and consume those messages. We need to create a project for our new Kafka consumer. We're going to keep it separate from the other backend project that we created and put it in its own namespace. Let's go to Openshift, create a project. I want to make sure I'm using the right project name, so we're going to call it Abe Korn Kafka Consumers. Let's just copy that, make sure we get it right. Oops. Okay. Now that we've created that namespace, let's create the image stream. So if you've watched the previous video, some of this will be repetitive. The first, so what we need to do is create an image stream. And that image stream you can think of as the same thing, essentially, as an image in Openshift. And it has to have the same name as the image that we're going to be pushing to Openshift. So OC, let's make sure we're in the right project. Okay. We are not. Okay, so OC project Abe Korn. Kafka consumers, OC create image stream, and we'll call that image stream trade Kafka consumers. All right, we have the image stream, and now we're going to push accordingly. First, let's tag the image correctly. We're going to tag the local trade Kafka consumers. I didn't show all of the steps to build this image, but if you watch the previous video and you hear some of the explanation, it would just be probably more repetition than we need to show. So I didn't show all of the steps, but we do have the final trade Kafka consumers image on our local machine, and we're going to tag it so that it matches. So this tag is going to match the exposed route of the registry and the namespace of the project that we just created, as well as the name of the image stream. All right. Now that we've tagged it, we can send it on its way. Again, this push command, has the exposed external route to the Openshift registry, the namespace, and the image stream name, and then TLS verify, because the registry is secured using SSL with self-signed certificates, and we want to ignore verifying those. Okay, and once that completes, we can run our application, and we'll show that step next. That image is now in Openshift, and let's take a look at the image stream to make sure it's correctly configured. We're going to go to Builds, Image Streams, and here is our image stream. We want to make sure that there is a pushed, right, there it is. Okay, so it looks good. The YAML file looks good. And we're going to now do what we did for the trade service application. We have to have a deployment config. Now remember, all of this build process we could have put into a build config, or and automatically let Openshift build our images and our layers for us and then trigger the deployment. But we're keeping things a little bit more manual so that we can see what is happening right under the covers. And what you would eventually want to do is use something, if you had a complicated build process, would be with, and also run some automated tests, you would be using something like the Jenkins pipelines or Tecton pipelines built into Openshift too. So keep that in mind, that you have that ability to do everything that we were just doing manually automatically inside Openshift. But right now, let's focus on what the deployment config has to have. And again, it looks a lot like the deployment config and the template that we had for the trade service. And the trade service template, remember, looked like this, but it had persistent storage volumes because we were storing Lucene indexes. But here it's a little more simple. We don't need persistent volume storage, because I'm not making this service stateful in any way. Let's take another look now at the code that we're going to be deploying. So what it does is we create a Kafka component. We're going to add that to an Apache camel context and configure it by setting the broker, the Kafka broker information. The URL is the external route to the Kafka broker. So if we go and look at, it's not the external route to the registry, and it's not the external route that we used when posting inside or putting inside Postman. It is so if we go back to the Kafka project, so my Kafka cluster, say OC get routes. What we're looking to add in this application is an external, and so we created that cluster in its own namespace, and we said that it should only be accessible in its own namespace. So I didn't configure it so that an application running in a different namespace could just use the service name to get access to the Kafka cluster. Instead, I exposed it with an external route. That way, if you were running a service outside of Openshift for whatever reason, you could still access it. And so it's a useful thing to see, how that works. And what we're using in the code is this bootstrap route. So my cluster Kafka bootstrap route here, and that's just pasted in there. Now I would, rather than put that directly as a hard-coded value, do what I'm doing here bringing that in as a property, a configured property. So one of the things, like this keystore that we've deployed using that Docker file, it's stored alongside the Docker file, and when the image is built, it pulls that, it adds that keystore to that location. But then I had to add a dynamic property for the difference between, let's say if I was developing on a Windows machine and I had a specific path to that file, or if I'm deploying to production, I'm on a Linux machine, and then that path is different, I want it to be something that changes dynamically. I would do the same thing. I'm just showing for this tutorial's purpose, showing the value of the URL to the broker. And what we have here then is this code, and this is deployed separate as its own service in its own namespace inside Openshift, and it knows nothing about the other trade application that generated the modification message. Also, the application that created the modification notice, or not the notice, but the event, knows nothing about the code that does the service of consuming the message and then notifying users. All the trade service, which is deployed in its own container, knows about is that, hey, I need to go and fire off a trade modified event, and the other systems will know what to do with that message. And so that's a nice way to decouple systems from each other, rather than having this application then call out real time, get all of the users that want a specific item, and then notify them at that, synchronously at that time. Or what I was doing previously, modifying the domain model so that each entry had a modified flag, and then a batch application would run and look for that modified flag. Here I don't have to modify anything to do with the domain model. I don't have to synchronously send out or a call to another service and know how to call that other service. All I have to do is know how to generate this trade entry modified event, essentially putting a record into that Outbox table. So it's a very nice way to decouple systems. And let's finish up here. We're going to switch back to the Abe Korn Kafka Consumers project. I already did that. If you look at the commands I did previously. So OC project, Abe Korn Kafka Consumers. I switched to that project, and then we're going to process that template that has the deployment config for our trade Kafka consumer service. So we're going to process this template, and that will create our service and trigger the deployment. All right, let's make sure everything looks correct. And if we're not in the right folder, it will tell us here. Probably not. Right. We have to get into the right folder. So we're not looking for the Docker files anymore. We're looking for that Openshift template directory that has our Git repository for that template. Okay, I just sometimes need to refresh my memory where I put things. And that will be inside GitLab. And no, I guess not. We're going to go, so CD OpenShift templates. And we're going into OCP4. Now we can go ahead and run that command to process. Let's see what we have now. So let's go back, look at our projects. So we have a deployment config. We've got 1 of 1 pods. and it's creating the container. Let's take a look at the log. If we haven't created the correct permissions for this, which I don't think we have, we're going to run into that permission error. So we'll have to fix that really quickly. I know that we have to do that. Let me just do a quick history for that command. So 984. All right, here we go. Pound 984. Okay, so now we can run our pod as root. So because we made that change, we got it in time, and the service now is starting up. Let's watch to make sure that it will successfully connect to our instance of Kafka. And start consuming messages. All right, looks like we're hitting that portion. Okay, I think we should be good to go. Let's take a look at what happens now in our application. So I'm logged in as Ben Stevenson, who wants one of my items. So let's double check to see which item it is, or which items that Ben Stevenson actually wants. Okay, so zombies, and let's see what condition each one of these things are in. All right, let's go to my matrix. So let's see what condition Ghost Pirates is in, for example. So new in box, and that is something that I added. So I'm going to, so there's no messages here about anything being modified yet. So I'm going to log out and log in as myself. Log in. And let's say I am an unscrupulous trader, and right before the trade ends, or during the trade before it ends, I go in and modify my item. Let me go to the trade, and I'm going to edit my items. And I'm going to edit my Ghost Pirate. So rather than being new in box, I am just going to say it's just okay. So I'm just okay shape. Quite a lot of scuffing on the box. And maybe even change it to acceptable. So I'm going to click submit and think, okay, I've tricked people and they're not going to know, and they're not going to track this. Well, now with our new event system, our venting system, we can real time send that message out, and then once our notification system is ready or not under load or what have you, it can consume the message and notify the user that that item has been modified. So let's log back in as Ben. And there should be a message here. And there wasn't a message, so we need to go back and find what was wrong. So this is good. So we're learning. And I've logged into the I've logged into Openshift, and I'm looking at the Trade Kafka consumer service, and what it's complaining about is this unknown host exception. And I have so this auth.abekorn.com, I have another service which we haven't transitioned yet, but it is still, so this URL and this subdomain are configured in Route 53 in Amazon. But what I mentioned before in, I think, what was it? So the previous episode for this tutorial. So you have to have both a public and private hosted zone. The private hosted zone is so that anything running, for instance, anything running in containers on our Openshift environment is inside of VPC and using a private network within Amazon, and it is not going to know about the DNS records that you've put into a public hosted zone. It needs to be in a private hosted zone associated with your VPC. So I've got that for Abe Korn. I've got a public and a private. In the public zone, we have a subdomain for our Keycloak auth server, identity provider. But we also have to now have that same record in a private hosted zone. And since we haven't moved it, we're still going to be using a different load balancer. So let me go and add that now. Let me create a record. Auth. It's going to be a CNAME record. And create. So let's hope now that, and that's one of the nice things too about event-driven architecture and our change data capture mechanism is, if it failed at first, we know where we left off, and that we know that that message that was sent to Kafka has not yet been consumed. So we should be able to fix the error and then pick up where we left off. So let's take a look at what's happening in our logs and see what our service is doing now. Okay, let's go back. Projects, Abe Korn Kafka cluster. Abe Korn Kafka consumers. Look at this pod and look at the logs. Let's take a look down here. Okay, looks a lot better now. And now let's go back to our application. Get started. And I've got another message. Hey, and here we are. So Ghost Pirates has been modified. So there's quite a lot of power with this method. So event-driven architecture, this is a little bit more contrived, but now with the ability to separate our services from each other so that they don't have to know what one, how one has to call the other. Rather, you do more of that choreographing of events throughout your system, and let the systems that are consuming and reacting to your events know what to do with them, rather than require the service that generated the event have to know how to command the other parts of your system to do what it's supposed to do. So in this case, we had our trade service fire off an event. We had a separate application running in its own namespace, in its own container, consume the event, and send out our notification in our discourse service here and tell Ben Stevenson that Dean has modified your wanted item. Ghost Pirates, please confirm that you want this item. And we could, along with the message, say exactly what had changed. That would be useful for including in this message too. And I'll probably update that in the future to do that. Congratulations for making it to the end. We had a lot of ground to cover. In the future, I think we'll focus on having some more succinct videos on interesting topics that will really push the application toward that microservice architecture in a meaningful way. And we did a lot of work here, so we have a good start. And I hope that will help you get a good start on your applications and your journeys to OpenShift 4 and microservice architecture. All right, thank you. Bye.